Welcome back. Before the break, we were looking at 3D problems and using compound and double angle formulas to help us solve 3D problems. Let's continue. In this example, a hot air balloon H is directly above a point B on the ground. Amy and Dave stand at A and D respectively, holding the two guy ropes, AH and AD in place. The distance between A and D is K meters. AD equals to 2x, HAB, which is the angle of elevation, is x, and we have that ABD is 90 minus x. Show that AB is equal to 2k sine of x. Okay, so let's just double check. ADB is this angle here, and this angle here, ADB is this angle here, and this angle here is 2x. HAB is x, so this angle here is x. It's the angle of elevation from A to H. And they've given us that ABD is 90 minus x, so we're talking about that angle. They want us to show them that AB is equal to 2k sine of x. Okay, so we need to find something. We need to find AB in terms of k and x. Okay, so they want us to find something about AB. Now, AB belongs to both triangles, this right angle triangle and this one ABD, the horizontal triangle. Obviously, we don't have enough information in the right angle triangle because we only have x. So we can't use the triangle. We're probably going to use triangle ABD in order to find AB. So let's check what we have. We're looking for that. We've got the angle across it. And if we look here, we've got a full pair of angles and its matching sides. So we've got this angle 90 minus x, as well as the side across it. We have this angle, and we're looking for AB, which means we can easily use the sine rule. So that's where we'll start. Okay, so in triangle ADB, using the sine rule, AB over the angle across it, so it's sine of 2x, will equal to, now remember we're going to use this matching pair, so we're going to start off with k over sine of 90 minus x. Okay, and already you're going to notice that this 2x is probably going to change 2x into what? We're going to use our double angle formula at some point, and we're probably going to end up changing this into 2 sine x cos x. So just keep that in mind. We're going to be using that somewhere. Okay, so first we'll multiply throughout by, we could have changed it in this step. Sorry, I've changed it in this step already. So we've changed it here. And now we're going to multiply throughout by 2 sine x, just to clean up some of the algebra. And so when we multiply that into the numerator. Now we just clean up and cancel out the 2 cos x. And we're left with AB is equal to k times 2 sine x. And rearranging that slightly, we got AB is equal to 2 times k times sine of x. And that's exactly what they asked us to find. Okay, there's another part to the question where they tell us, hence, show that the length of rope AH is equal to 2k tan x. So remember, we found AB equal to that already. So we've got some expression for AB, which means we kind of have this side here. And they want us to find this side here. So, and we have angle x here. So we have the adjacent, and they want us to find the hypotenuse. So because we're dealing with adjacent and hypotenuse, we're talking about cos. So because this is a right angle triangle, we don't need to use any fancy trigonometry. We just got to use the SOHCAHTOA. So we can use cos in this case. So ABH, in triangle ABH, cos of x is equal to adjacent. So it's going to equal to AB over your hypotenuse, which is our AH. Now we're going to just rearrange this to make AH the subject of the formula. So AH is equal to AB over cos of x. But now I can substitute this for AB there. So let's do that quickly. Okay, so 2k sine x goes in my numerator. And what did they want us to prove? They want us to prove AH is equal to 2k times tan of x. And I know that this gives me what? Sine x over tan x, we know that tan of x is equal to sine of x over cos of x. So, in other words, we've proved exactly what they want because now we've got that 2k tan x is equal to AH. Okay, the third part of this question, it tells us, they're giving us now values to substitute. They tell us k is 40, x is 23, HD is equal to 31,8 meters. Calculate theta, the angle between the two ropes. So let's see what they've given us. They've given us, now we know that k is equal to 40 meters. X is equal to 23 degrees. Okay, and they've given us that HD is equal to 31,8 meters. Now remember, they want us to calculate theta. So we're talking about this inclined plane here. With the triangle we're dealing with now is we're talking about this triangle here. Okay, and in this triangle we have theta. So in the triangle HAD we have theta. We've got k is equal to 40. Okay, and we have this side here 31,8. But remember earlier we did find an expression for AH. Okay, so because we kind of have an expression for AH, we can substitute into that. So let's do that. AH is equal to 2k tan x is what we found in B. So now I'm going to substitute this 40 in for k, and for x I'm going to substitute 23. So we're going to end up with 2 times 40 times tan of 23 degrees. So now we're going to find our value for AH. So now we have that this side here is equal to 33,95 meters. Okay, now let's go back to our thing. Remember we were looking for theta. Because we're looking for theta, we're going to see what we have. We've got the side across it, we've got that side, and we've got that side. So we actually have 3 sides, and we're looking for an angle. And we know anytime we have 3 sides and we're looking for an angle, we're going to use cos rule. And specifically, we're going to use cos rule where we're going to start off with 40 squared on the left-hand side. So let's see how we're going to do that. We're going to say in triangle HAD, AD squared is equal to, so AD squared will equal to AH squared plus HD squared, AH, HD, and remember because we started off with AD, we're going to end with the angle across from it, and the angle across from AD squared is theta. Now we're going to rearrange this because remember we are looking for cos of theta. So we're going to make cos of theta the subject of the formula. So it will be AH squared plus HD squared minus AD squared divided by 2AH HD. Okay, we've done this conversion lots of times. Now we're going to go and substitute into the equation. So let's go and substitute into the equation. That's where we were at, and remember we had calculated, we should have this in the memory of our calculator. We calculated AH earlier. So we're going to substitute that in. So we're going to say AH squared plus HD squared, and remember HD is 31,8 minus 40 squared equals to 2 times 33,9579 times 31,8. And remember again, because we're finding cos of theta, when we're doing our calculator work, we got to use shift cos when we're finding the angle. Okay, so basically we're going to end up with cos of theta equals to this expression here, and we're going to find theta from there, and we're going to end up with theta roughly equal to 74,85 once we've rounded off to 2 decimal places. Okay, it's time for a quick ad break. See you after this.